In this type 2 of problems, we'll learn about work done by a variable force. So in the first question, we have to find out the work done of this force, which is given as 4x I cap, and this force is displacing the object on the x-axis from x is equal to 2 to x is equal to 4. You can see that this force is variable as it depends on the x, and this force is acting in the x-axis direction. So first of all, you need to identify the path on which this particle would be displaced, and we can see that this particle is being displaced on x-axis from x is equal to 2 to x is equal to 4. So we need to write down the ds vector. So ds vector here would be dx I cap, because the displacement of the particle is in the x-axis, and you have to consider a very small element of displacement in the x-axis. So the work done dw would be equal to f dot dx, and the total work done will be equal to integration f dot dx. Now substituting the values of f and dx, this is 4x I cap with it is dot with dx I cap. Now I dot I is 1, so work done will be integration 4x dx. Integrating from limit 2 to 4, we would get x dx integration is x square by 2, so it would be 2x square integrating from 2 to 4. So work done will be equal to 2, 4 square is 16 minus 4. Now work done will be 24 joules. Okay, now we move on the next question. Now in this question, the force which is given to us is equal to F is equal to 4x and j cap. So it is very important to note that this force is a variable force and it is depending on x coordinate, but the direction of this force is in the y-axis, is towards the y-axis. So but the object is moving on the x-axis from x is equal to 2 to x is equal to 4. So by this information we can say that the displacement vector ds will be dx I cap, and hence the work done will be integration f dot ds. Now we can say that integration f dot ds will be 4x into dx, but it would be I cap dot j cap, which is 0, we know that, and this can be easily predicted that if this particle is moving on the x-axis from x is equal to 2 to x is equal to 4, and the force is acting continuously on towards the y-axis, then the angle between the force and the displacement is 90 degree, and hence the work done by this force will be 0. Now we move on the next question. Now in this question we are given that the force is equal to 2x I cap plus x square j cap, and this is a two-dimensional force, and the particle is being displaced on the x-axis from x is equal to 2 to x is equal to 4. So the displacement vector ds vector will be dx I cap. Now the work done dw will be equal to f dot ds, and work done after integration will be equal to integration of 2x I cap plus x square j cap dot with ds, which is dx I cap. Now we know that that I dot j will be 0, therefore it would be only 2x dx, and integrating from 2 to 4. So the answer will be x square, and 2 will cancel out. Now it will be integrated from 2 to 4, and therefore the answer is 16 minus 4, that is 12 joules. Now we move on the next question. In this question, the force which is given to us is F is equal to 2x I cap plus x square j cap, and the displacement of the object is on the y-axis from y is equal to 2 to y is equal to 4. So the displacement vector ds will be dy j cap, and this is the force vector. So the work done will be integration f dot ds, and integration of f dot ds will be x square dy. Now we cannot integrate this term x square dy because the information of the path on which we are moving from y is equal to 2 to y is equal to 4 is not given to us, and that if it is y-axis, then x would be equal to 0. So let us assume that on y-axis I am moving. So on y-axis x would be equal to 0, therefore the work done will be equal to 0. But on some other line, let's suppose we are moving on x is equal to c. So work done will be equal to integration of c square dy, limit from 2 to 4, and this will be c square into 4 minus 2. So this work done will be 2c square. So in this question, the information of the path is required on which we are displacing the object from y is equal to 2, from y is equal to 2 to y is equal to 4. Therefore, we can integrate like that. So we move on the next question now. In this question, the force which is given to us is F is equal to x square I cap, and we need to find out the work done in displacing our object from point A to B on this line, on this straight line. Now we know that this force is pointing in x-axis. So if we are moving in two-dimensional line, then what we can do, that we can let the displacement as dx I cap plus dy j cap, due to the fact that we are in the xy plane, we are moving in a xy plane, and our displacement is two-dimensional. So the element which you have to assume should be two-dimensional in the same plane. So the force will be equal to x square I cap, and hence the work done will be integration of f dot ds. Now substituting these values here, so it would be x square I cap dot with dx I cap plus dy j cap. So work done will be equal to integration of x square dx. Limit will be from 0 to 4, and you have to remember one thing, that you are integrating with respect to x, so the limits should be of x coordinates only. So x square dx will be x cube by 3, and it is integrated from 0 to 4. So this will be 64 by 3 joules. Now what happens if the force was given to us, if F was given as x square j cap? Now what will happen? Now in this case, if this force was given to us, then the displacement ds would remain the same, and displacement would be dx I cap plus dy j cap, and work done will be integration f dot ds, and work done will be integration. Now when you will multiply these this f and ds with scalar product, then j cap will multiply, j cap dot j cap will be 1 and j cap dot I cap will be 0. So it would be x squared dy. Now to integrate x square with respect to y, you need the information of the path on which this particle is being displaced. So the path is already given to us, that it is a straight line AB on which this particle is taken from A to B. So we need to find out the relationship between x and y, and which will be the relation of the equation of the path. Now for this straight line, AB, this is y is equal to mx and y will be equal to m. M is the slope, and slope of this line is y upon x, which is 3 by 4 into x. So x is equal to 4 by 3 of y. Therefore, if I substitute these values in the work done equation, then w will be equal to integration of x square dy. So x square, either we can replace x with y or we can replace dy with dx. So I'm replacing dy with dx. So dx from this equation, dx will be equal to 4 by 3 of dy, and dy will be equal to 3 by 4 of dx. So by putting this x square into 3 by 4 of dx, work done will be 3 by 4 into x cube by 3, integrating from again we have to put the limits of x coordinates, so integrating from 0 to 4, and this work done will be 64 by 4, which is equal to 16. Okay, so this was the question of work done by the variable force. Now we move on the next question. In this question, we have to find out the work done of this force in moving a particle from A to B on this line shown. So again, this is a two-dimensional line, and hence we can assume the displacement vector as dx I cap plus dy j cap, because this line is also lying in xy plane. Now the force vector is also equal to x I cap plus y j cap, and the work done will be integration of f dot ds. Now work done will be integration f will be x I cap plus y j cap, integrating it from with ds. ds is dx I cap plus dy j cap, and the limit will be applied later on as we will get x dx plus integration y dy. Now in the first term, the limit will be of x coordinate, and hence it would be 0 to 3, and in the second term the limit will be of y coordinate, and hence it would be 0 to 4. So work done will be equal to x square by 2 limit 0 to 3 plus y square by 2 limit 0 to 4. So work done will be equal to 9 upon 2 joules plus that 16 upon 2 joules. So work done will be equal to 9 upon 2 plus 8, and this will be equal to 25 by 2 joules. Okay, now we move on the next question. In this question, we have to find out the work done in moving a particle from A to B, and the force which is given to us is F is equal to y I cap plus x j cap. Now this displacement ds will be dx I cap plus dy j cap, and work done will be integration of f dot ds. Now work done will be integration of y dx plus x dy, and in this question we do not need the information of the path because this y dx plus x dy is integration d of xy. If you will differentiate, I am showing you here, because d of xy is equal to dx into y plus dy into x. So the integration of this term will be d of xy, and the differentiation of d of xy will be this term. So as we know that integration of dx, for example, integration of dx is equal to x, therefore integration of d of xy will be equal to xy, and this is not an indefinite integration because we are putting the limits, and the limits would be from 0, 0 to 3, 4. So work done will be 12 joules. Now we move on the next question. In this question you can see that there is a force F which is k x upon x square plus y square to the power 3 by 2 I cap plus this ky upon x square plus y square to the power 3 by 2 j cap. Now we are moving a particle on a circular path. I am drawing the circular path. We are moving a particle from a comma 0, this point a comma 0 to 0 comma a, and this is a circle, quarter circle whose center is origin. So we need to find out the work done by this force. Now if I know the path is circular, so I can write the equation of the path. So the equation of path will be x square plus y square is equal to a square. This is the equation of a circle whose radius is a and whose center is 0, 0. Now if we substitute these values here, so f will be equal to k, which is common, x upon a cube plus y upon a cube. This is with I cap and this is with j cap. Okay, so taking out this a cube common, this is k upon a cube x I cap plus y j cap. Now if we point out a point which has a coordinate of x comma y, so this vector, force vector, will be pointing like that, k by a cube x I cap plus y j cap, and hence this is a radial force. Radial force is a force which is acting from the center along with the radius in the direction of the radius, and the displacement of this object is along with the circle. So at any point of the circle, the displacement and force will be perpendicular to each other, because displacement is tangential and force is radial. So the angle between ds and f will be 90 degree, and therefore work done which is F dot ds will be 0. So the work done by this force in displacing this particle from first point to second point will be 0. Thank you. In this question, the force which is given to us is as a function of time. You can see that. And we have to find out the work done by this force in 1 second, given that the initial velocity of the particle is this. So this is the first unique question in which the force is as a function of time, and we have not studied these kind of questions till now. But in these questions in which force is a function of time, we need to find out F dt. Now what is F dt? So first of all, we all know that momentum P is equal to dF that force is equal to dP by dt. This is rate of change of momentum. We all know that. And therefore dP is equal to F dt. Now if I integrate this complete equation, then this is delta P, change in momentum, will be equal to integration of F dt. Now delta P here, now F is given as 4 I cap plus 12 T square J cap. This is force, and if I integrate it with respect to time, then the limit would be 0 to 1, because I have to find out the work done in 1 second. So delta P will be delta P will be equal to 4 T, limit 0 to 1 I cap, plus 4 T cube, limit 0 to 1 J cap. Here the integration of 12 T square will be 12 T cube by 3, and 12 will cancel out with 3, remaining 4, and therefore delta P will be 4 I cap plus 4 J cap. Now this is the change in momentum. Obviously we know that delta P is also equal to m delta V. Now delta P is 4 I cap plus 4 J cap, and that is equal to 4 delta V. So delta V vector is equal to I cap plus J cap. Now delta V is V final minus V initial is equal to I cap plus J cap, and V final is equal to I cap plus J cap plus V initial, and V initial is 2 I cap plus J cap plus 2K cap. Now V final will be equal to 3 I cap plus 2 J cap plus 2K cap. This is the final velocity. Now if we have to find out the work done, then work done is equal to change in kinetic energy of the body. So the final kinetic energy will be half m V final square, where V final is the final speed, and initial kinetic energy will be half m V initial square. So work done will be equal to half m V final square minus V initial square, and V final is equal to the magnitude of this vector. So this is equal to root of 17, and V initial is equal to 3. So the work done in 1 second will be equal to half, mass is 4, and V final square is 17 and V initial square is 9. So this will be, work done will be equal to 16 joules. So the correct option will be option number D. So in these kind of questions in which we are given a force which is dependent on the time. So we need to find out F dt, and that F dt will give us the change in momentum, and we need to find out the final momentum, and the final momentum will give us the final velocity, and we know that the work done is equal to change in kinetic energy. So we will put the values in the equation that W is equal to K final minus K initial. So this is the method to solve these kind of questions. Now I move on the next question. In this question, this force is given to us, and we need to find out the work done in taking a particle from from a point a comma 0, which is on the x-axis, a comma 0, to a point a comma a, which is here. Now we are taking this particle from origin to this point and then to this point, but we need to find out the work done, total work done by this force in taking the particle from O to B via A. Okay, now if I calculate the work done by integration, then I know that dW is equal to F dot ds, and the ds here will be two-dimensional elemental displacement, which is dx I cap plus dy j cap. So dW can be written as F, in fact F is equal to minus K y I cap plus x j cap dot with dx I cap plus dy j cap. Now the total work done will be integration of this one y dx plus x dy. Now work done will be minus k, and it can be written as d of xy. As we all know that differentiation of x into y will be given by the equation x dy plus y dx. So if I integrate this equation, then this will give d of xy. So the differentiation of d of xy is this, and its integration will be minus k of x into y, because we know that integration of dx is equal to x. Similarly, the integration of d of xy will be equal to xy, and applying the limit of, now this also leads us to a conclusion that this work done is not dependent on the path, and it is independent of the path, because we didn't required any knowledge of path to evaluate this work done. So we can say that this force is conservative in nature, and therefore the work done will be equal to minus k, and applying the limits from origin to that point, so 0, 0 to a, a. So it would be minus k a square, and therefore the correct option will be option number C. Now we move on the next question. In this question, we are given with a force which is dependent on the velocity of the particle, and due to this force, the particle is moving in a straight line in the direction of this force with the velocity v. So we need to find out the work done by this force in time t. So this is a very simple question, as we can see that the instantaneous power delivered by any force is always equal to F dot V. Now instantaneous power is also equal to dW by dt, and this F is equal to K by V, and this is V, and cos 0 is 1. So dW will be equal to K dt. Now integrating this, the work done is 0 to W, in time t is 0 to t. So the work done will be K into t. So the correct option will be option number C. Now I move on the next question. In this question, we need to find out the total work done by this force in the complete motion. So the motion ends at 15 meters and we need to find out the work done. Now in these kind of questions, for fx, for fx graphs, the area bounded between the graph and x-axis gives the work done. And also the fact that the area which is above the x-axis, area above x-axis, or we can say that displacement axis, here the displacement has been taken on the x-axis, is equal to positive work done, positive delta W, change in work done, or I can say positive work done, and area below the x-axis, obviously in fourth quadrant, and this is in first quadrant, denotes negative work done. Now why is this happening, that area above this displacement axis denotes positive work done and area below this axis denotes negative work done? Because in this first quadrant, the force and displacement both are positive, which means the angle between them is 0 degree. Or in the fourth quadrant, force is negative and displacement is positive, which means the angle between them is 180 degree. So this is easily understandable that in the first quadrant the work done would be positive and in the second quadrant the work done would be negative. So to find out the net work done, we need to find out the net area, which can be calculated by subtracting these two areas. So area of this upper graph is A1 and this is A2. So the net work done will be A1 minus A2. So A1 is equal to half base into height. Base is 10 and height is 10. So the area will be equal to 50 and A1, and this A2 will be equal to half base into height. Now base is 5 and height is 10. You also need to understand this thing, that you are not taking these coordinates. Okay, you are taking just these heights. So you are putting the magnitudes and you are just finding out the area. You are not putting the coordinates. So don't do this mistake of putting here minus 10. So this A2 will be equal to 25. Now these are the magnitudes of area, and area cannot be negative. Now the work done, net work done, will be equal to A1 minus A2. So this is 50 minus 25, and that would be 25 joules. Okay. Now I move on the next question. In this question, there is a graph which is given between the force and the time, and we are also given that initial velocity of the object which is moving was 0. It is given in the question, and we need to find out the work done, total work done in 10 seconds. This is the question. So if the graph between force and time is given, then we should wonder that the area of ft graph will give us the change in momentum. This is very important, that area of ft graph is f dt, and f dt is change in momentum. So the area of force time graph bounded with the time axis obviously will give us the change in momentum, and hence by calculating the change in momentum we can find out the work done, and I'll show you how. So first of all, we are finding out the area, and the area here A will be equal to half 10 into 10, which is equal to 50. Now this is the total change in momentum, which is 50, and change in momentum will be P final minus P initial. So this is equal to 50. So P final will be equal to 50 because P initial is 0. We are given that the initial velocity was 0. Now we need to find out the final velocity obviously. So this P final is equal to m into V final. This is equal to 50, and V final is equal to 50 upon mass. The mass is 2 kg, and that will be equal to 25 meters per second. So V final will be equal to 25 meters per second, and to calculate the work done we need to write the equation as half m V final square minus V initial square, because we know that work done is also equal to change in kinetic energy. Okay, so work done will be equal to half m. The mass is given as 2, and V final square is 625 minus V initial square is 0. So that is the value of work done, which is 625 joules. Okay, now we move on the next question.